Hi, Mark Heath here, and welcome to Module 7 of More Effective LINQ. In this module, we'll be looking at how you can optimize the performance of your LINQ queries. Now, if you've been following along with this course, then you'll have seen and hopefully tried for yourself a few of our LINQ challenges. And we've seen how a LINQ pipeline can be constructed that solves a complex problem in just a single C# expression. But let's imagine that we came up with 3 alternative solutions to one of these LINQ challenges. Let's call them solutions A, B and C. And imagine that all 3 produce the correct answer, but solution A is the most concise, it contains the fewest characters of code. Solution B is the most readable, it's very easy to understand what's going on. And solution C is the fastest performing, it produces results more quickly than the other solutions. Now, which of these 3 solutions would you say is the best one? Well, if you watched the earlier module in this course on clean code, then you'd be right in assuming that my default position on this question is that solution B would be my preferred option. Readable code in most cases is preferable to code that runs a bit quicker but's hard to understand and maintain. However, there certainly are times when you're writing LINQ queries where performance is critical. And you also need to be aware that it's possible with LINQ to make some silly mistakes that make your queries take far longer than they need to execute. For example, you might remember this code snippet that we looked at in Module 4, when we were trying to work around the fact that the standard LINQ library doesn't have a maxBy method. And so we came up with this hacky workaround to find the book with the most pages. And we saw that this LINQ query will indeed successfully find the book with the most pages, but for a collection of 1,000 books, this code will need to make 1,000,000 calls to this internal lambda expression, because for each one of those 1,000 books, the max method requires us to iterate through all 1,000 of them again. Of course, in this example, the fix is relatively straightforward. Just pre-calculate the maximum like this, and of course, if you use MoreLINQ, as we recommended, it's even easier. But this simple example shows how failing to think about what will actually happen when your LINQ queries are executed can result in some very poorly performing code. So in this module, we'll look at when and how to performance tune your LINQ queries. And we'll see that LINQ isn't always as fast as a plain old for each loop. But I'll be introducing you to some tools and techniques that can speed your LINQ queries up, including the parallel LINQ extensions, which in some circumstances can massively improve the performance of your LINQ queries. We'll also look at the importance of knowing what's going on under the hood, which can help you to avoid accidentally creating performance problems. And finally in this module, we'll discuss the performance issues surrounding LINQ to databases, such as when you're using Entity Framework. So let's get started.